much, so get some space here. Could I have a student to read application number 2 there? There's only 2 word problems. Application number 2. And let's see, what on earth, how does it tie in with what we're doing today? Anyone? Read first. Yes.
SMC under construction.
Oh, let's try number 2. Problem number 2.
The stone is thrown upwards from the top of the building. The height is feet above the ground after 3 seconds is given by H the equal.
You guys don't have a handout?
We got a different one.
Oh, you got a
Modern on that one, Jen.
Hang on. Well, that's on the back, the other side. Oh, we don't have that. Yeah, thank you. Okay. Sorry, try that again.
A stone is thrown upwards from the top of the building. Its height in feet above the ground after 3 seconds is given by H equal -16 t squared plus 48 t plus 32. What is the maximum height reached by the stone? How many seconds does it take to reach this height? How many seconds will it take for the stone to reach the ground?
Here we go, guys. She's telling me, Professor, this says this. I think she described it as I'm on top of a building and I'm tossing a stone up into the air. Was that it? I am on top of a building. Okay. So she's saying, Professor, it looks like this. We're doing something like this. Now we're hoping it takes a shape like this, the stone's path, which I'm trying to make it take the shape of a parabola, so I can apply what she read to me. Now she did give me a formula that this path, the blue, follows. I think it's a quadratic. Read that to me. H of t, was it?
H of t equals -16 t squared
Negative 16 t squared.
plus 48 t
Okay.
plus 32.
Plus 32. Beautiful. Therefore, since they gave that to me, I know it's a parabola. It's a quadratic. So the path of the stone, after it's tossed up into the air from the top of the building, we're just going to stop us there somewhere, and then fall back to the ground. Okay? Now, the first question I think was, she wants me to find,
What is the maximum height reached by the stone?
here we go. They would go from the ground. What is the maximum height? This, that stone reaches. Andrew, go for it.
Well, I have a question.
Yeah, go.
Would our maximum height be our bird time?
Exactly. They're asking you to find the vertex.
I'm not looking for an actual height.
You said it described perfectly. The maximum height is the vertex. Now, I'm not gonna find it through completion of the square. I'm not gonna divide everything by -16 that she gave me and put the blanks on each side. That would be lengthy. I'm gonna use the negative b over 2a. Guys, if I use the negative b over 2a to find the x coordinate up there, x is equal to negative b over 2a. In my case, that's negative 48 from the quadratic, 2 times a negative 16. Looks like it's 40, positive answer, 48 over 32. Is it? And I think the best you can do is 48 over 32, maybe reduce it down by 16. I think it was down by 16. Into what, 3 halves? 3 halves. Now, you said, Professor, okay, make some sense of this problem she read to us though. Tell me what it means. This is written in terms of t. Usually it's x. Usually it's f of x or h of x. This was in terms of t. Where that t represents what? Time. So what we have actually found, put a t here rather than x. We've actually found first the time it takes for it to reach that maximum height after it's released and thrown into the air. So, what were the units here, seconds?
Second.
Yeah, so it's gonna take 1 1/2, 3/2 seconds. That part's out of the way. So after it's released, goes up in the air, it's gonna take 1 1/2 seconds for it to reach that point there. Now though, I think she's asking me, Professor, how high is it after it reaches the maximum height up there? How high is it from the ground at that point? Guys, tell me a quick way to find how high is it now? Okay, tell me again. Okay, h of, she said, just go back, Professor, and plug in 3/2. And I will. It'll look like this. Like this. And all I need to do is crunch the numbers. But be careful. I guess this is -16/9/4. I'll come back to it. Got to do a little canceling on that second term. 2 into 48, that's 24. That's a 72. 3 times 24. Plus 32. Going back to the first term, I can cancel 4 into 16, just math. That's -36. Plus 72. Plus 32. Now, if there's no mistake, I think that's 68 altogether, is it? Put all those numbers together, is it 68? I think 68. And I think she gave me for the units for the height to be feet. I've answered the question. So what's the highest it's going to go in the air from the ground? 68 feet. How long after it's released from the top of that building will that happen? 1 1/2 seconds. Yeah. Oh, right. Exactly. Make sense, guys? 1 1/2 seconds, 68 feet, and we answer that question in no time. Now, you guys are moving on into maybe the sciences. Now, some students maybe taking physics or chemistry or something later on besides just math. If you take especially physics, or maybe that's some physics back in high school, usually this in the blue is not given to you. We in math, we give it to you. If you're in physics, they usually ask you to form this equation yourself. And let me just throw it out there. Does anyone recall something, if you had a little physics, somehow, how did they come up with those standard numbers that you see? What might be involved is that stone, if it's released, what might be involved is that the stone is right? What may have an effect on its path? Here's something.
Wind, gravity.
Gravity, and that guess what? That gravity factor is clear is constant. Okay, they will show you physics exactly where that why that is -16. There's something about gravity having an effect on that stone. This, of course, all this will be given to you in my class. This has something to do with the velocity. How fast was the stone moving? And guess what this was? Guess what the 32, in my case, represents from physics? The height of the building. So all those numbers play a part in that formula. But I'm not teaching physics, you're not taking physics. That's why we in Math 2 and Math 7, we get the formula 2. Then you go from there. Okay? Wow, that's answered. But I think there's one more item here. They're saying, yeah, Professor, that's good, but here we go, released. It's going to reach its maximum height here, 1 1/2 seconds, a maximum height of 68 feet. But it is going to continue and finally drop back down to the ground. Now she's saying, Professor, to finish the problem up altogether, how many seconds will it take for that stone to hit the ground? I wish I could ask you at what velocity does it hit the ground, but that's physics. I'm asking today, how much time does it take for it, after it's released, for it to hit the ground? Oh, beautiful. He's saying x-intercepts. Look at this. He said, Professor, you're down here somewhat like this. So he's thinking about x-intercepts here. Right? And to find an x-intercept, what we do?
Y equals 0.
Okay, y is equal to 0.
I mean.
No, you're correct, 100%. So when you say y is equal to 0, that's what we do. We find the x-intercept, and you hit the ground. That's h of t, that's like y here. That's my function. So he said, Professor, replace that by 0. I'm gonna put this in blue. Replace that left-hand side with 0, and you've got this remaining. You set the function equal to 0. By the way, does it make sense if you hit the ground, you're at 0 level? The height doesn't exist. Height's 0. So replace this side here, which is height, by 0. And you know it's like an x-intercept. Guys, to solve that quadratic, I'm going to divide everything by -16 to help myself out, both sides. 0 is equal to division by -16, t squared, minus 3t, looks like a -2. Step back and look at it. Divide by -16. It looks good. You got to solve that quadratic and find the times, or the time it's going to take to hit the ground. This will not factor. I thought it would factor. It's been so nice if it would. It's not going to factor. Use the quadratic formula maybe, and you end up with t is equal to, by formula, -3. So I'm going to close down with this. I'll put all the numbers in for you. That's negative b plus or minus square root b squared is -3 squared, quadratic, subtract 4 times a is a 1, c is a -2, all over 2 times 1, you step back and look at it, make sure I put all those in correctly. Clean this up, t is equal to 3 plus minus, guys, underneath there is how much? Well, I hope I don't have a mistake. What is it? Oh, I hope it's not a negative. But if it's a negative, we've done something wrong.
1.
What is that underneath there altogether? Be careful.
17.
Yeah, I think it's 17. I think it's 9 plus 8. So square root 17, which is good, it's positive, all over 2. Now to finish this up and make a complete answer for UCLA, there's a wait, now you got 2 options here. Are you going to have 2 times professor that hits the ground? It's going to hit the ground twice? Unless something strange, and when it hits, it bounces back and comes back down again. Well, I don't think I'm going to accept both answers. And if I separate these, one time to consider is this. And the other one, if I separate it from the quadratic formula, is this. Anyone tell me maybe which one am I going to have to rule out?
The upper one.
The bottom one.
Why is the bottom one here? Will that give you a negative answer? Because I think square root 16 is 4 point something. Not 16, 17. Square root 17 4 point something? So would that give me 3, subtract 4 point something, would that give me a negative altogether? So it looks like that has to be ruled out. Guys, this one is the reasonable one. And I know there's a square root 17, you don't have calculators in your exams or quizzes. So you have to leave it like that, you can approximate it. Square root 17 is what, 4 point something? Add 3 to it is 7 point something. Divided by 2, 7 point something divided by 2 is what, 3 point something? So between what, 3 and 4, we're trying to find time here, 3 and 4 seconds maybe, something like that. Whoa, Andrew, what was that question?
Oh, what was it? I thought you asked why it can't be a negative 1.
Well, it cannot be this one.
Because it can't go underground.
Oh, no, the time can't be negative.
Yeah.
This is t, time, we're not accepting time as negative. No, let's go into a different zone of some sort, but I wasn't there. Okay. Guys, make sense? I think we did a good job on, who would have thought, just one little item, quadratic function, took all this time, this discussion, quadratic function, completes the square, put it in that form, find the vertex. My goodness, we did an application. Oh, we did a graph of a quadratic. Took all this time. I'm taking my time here, it's 3 o'clock already. Now, I know I got to get the quizzes back to you. I'm looking forward to the exam tomorrow. You may not be. I'm looking forward to it. But I want to, and I know how I am, I'll probably sit down and start scoring. I said Saturday morning. I'll probably start scoring Friday night. Just have no life. I'm gonna start scoring math papers. And seeing how my students are doing. Now, I'm getting to know you through the quizzes. Some students are so neat and organized and follow everything, and everything's organized and follows one after the other. Some are all scattered up here and scattered there and here and there and follow my arrow and the answer's over here, and finally I see the answer on the wall over there. Wow, are you kidding? You can't do that business. We must keep all this organized on the exam tomorrow, for sure. Okay, I'll have those quizzes back to you here shortly. I want you to try one problem as I'm busy, returning papers. Tomorrow's exam will cover all of chapter 1. That means all that we've covered in this class in chapter 1. I think the last section is 1.6. And I think 1.6 was those application problems. And did I not tell you yesterday for the application problem, I'm gonna be nice. For your application word problem, it's gonna be one directly taken from that handout. So I don't like the word memory, but you guys who have a good memory, if you memorize the approach that we had on all 4, you say, he's gonna choose one of these for the word problem. I wanna get those 12 points for that word problem. So I'm gonna just try to memorize the best I can. I think that's 1.6. I got, hang on, just give you some information here. 1.6, yes, are the applications. Just a little discussion about what this is before I take the test. So, those 4, and I think you check, what June's been sent out to us. Oh, check. She even has the one with the water being poured into the cone. Have you guys checked her notes yet? She even has it in color. She even has it in color there. The water is blue and it's rising. And as I look at it myself, I can almost visualize it. My goodness, June, it looks like where you draw it is actually rising in front of me. Okay, so look at her. She has a solution to this. So guys, it could be the cone problem, the water problem being poured in. It could be that box problem. It could be, I think we had 2 box problems. One where I cut out the little squares at each corner, remember? Folded up the sides, it could be that one. Or it could be the one where they ask you to find the surface area of the box. We had to take the, I think the box was open at the top. And you had to consider all 5 pieces to it and add them up. You remember that one? And I think the last one was the wire problem. All I can say is, no one. No one. And you don't know which one we'll choose. Okay, so you know one. And I'll get it exactly like from the handout. Now, 1.4, not 1.4, 1.5. 1.5, I think, for these. If I'm not mistaken. Those are the transformations. So you might see something, some basic transformation problem. You have to shift to the left, shift to the right, shift up, shift down, reflect. Maybe one like that. We've done those in class, that means ready for something like that. And also, I gave you the handouts. So do follow that handout. The review for the test. That's a nice handout there. I'm just pointing out things right quickly. I think also we did something with piecewise function. You'll have a piecewise function on there. By the way, did I give you one to practice with on the review itself? I did. Didn't I? That was a piecewise function there. And I think we did it with little tables. You'll use the little strategy where you put a little table and block points. That's what we did. To get the pieces and practice a little bit, and you'll see what happens on the piecewise function. And then guys, everything else is on your handout. Domain, domain, domain. Domain, you got, I think I had 5 or 6 find the domain, find the domain, find the domain. Before I quiet, right quickly. Okay. So you see a function that looks like that. I made that up quickly, then it work. As you find the domain. Don't solve it, find the domain. I think most people say, well, first professor, that square root tells me this. This underneath here, it's gotta be this. Which I give you partial credit for showing that. That's not all the domain, but that's true. Down here, that might factor, and I did it real quickly. I think it factors into that. Which tells me, in addition, you cannot let x be 3, and cannot let x be what? 2. Oh, that's 1. 2. Is it 2? Yeah. Now, can I put all that together? Let's see if it'll work for me. And answer this. But it says, it's supposed to be, oh, hold on here. I made up something really crazy then. It says greater or equal to 3, but you can't use 3. Ah. What's the best I could do here then? Let's do a visual here. 3, I can't let x be 3 because of this condition here. I thought I could. And x can't be 2. And x must be greater than or equal to 3, so it's over here. Guys, I created one that's a little crazy, but here goes. That takes care of that. And you cannot let x be 2 bad 2's on the other side. After all that effort in this creative problem right quick, what's my domain? What would you say the domain is? Is this included at all? No, I was hoping it will be on the other side. I'm going to change things. Let's say it was on the other side, just to point out something. Suppose this had been a 4, and it's supposed to be open. Now, can someone tell me the domain?
Parentheses, 3, 4.
3 up to 4, 11. Tell me more.
And then parentheses, 4, 3.
Who's talking to me? Woo, perfect, perfect. You guys agree? Thank you. You guys be ready for domain? I'm expecting some good scores from this. Oh my goodness. Now, Mr. Professor, get my quiz back to me, please. I want to look at the quiz. What's going on? Now, guys, do we have an idea now what the exam will cover? All of chapter 1. Everything we've done in chapter 1. That's it. Not for me to parabolas. And all this business. Later on. Okay, so I should get some good results. Yes?
Will we just memorize the difference of cubes?
Oh, now, PK has the difference of cubes and sum of cubes formula she gave us in class, true? At this point, if you need it, I'm gonna place it on the side. I'll have it on the test. If you run to one where you have to use it, I'll have that formula for you.
Alright, thank you.
I'll be nice to you on that. Okay, guys, I want to try something here. Drop this in and I'll get those quizzes to you. Oh, here we go. I want you to try, just on a scratch sheet of paper or in your notes, find the zeros. And that's somehow how I'm gonna word this. Find the zeros of this function. Now, if I word it like that, guys, I did not use the word real, find the real zeros, I didn't use that. I didn't use the word complex. What do you think's implied if they should write that, just say find the zeros? In other words, can you imply, if the implication, find them all? Okay, so if you say just find the zeros, you gotta find them all, which means there might be some eyes in there. Guys, practice with that, try to find those 4 zeros. I think it'll be pretty easy for us. June. Straight for it. Melanie. Now they're telling me that you're fucking messed up. Rena. Where's Philip? Is it Basil? Basil?
Yes,
Am I pronouncing it correctly or not?
Basil.
Basil. Selena. Selena. Joseph. Did you see where you lost that one? I said, just see if you got the- Wayne, where's Wayne? Zoe. Rubio. Gia, you got to try Gia.
Do you know where the four come from?
I said.
In the interval? Where did the four come from? Is it a different person?
Oh, he just made it up.
Elvire. Did you look at my solutions when I sent them out? I know. N-C-H-E, here. Where's Jack? Nikki? Where's Elena? Elena. Ian? Is it Lynn? I think the last name, Lynn, L-I-N? Anthony. Oh, boy. Whoa, whoa, whoa. Let's see if I'm right. Is it Bonnie or? Isn't it? I don't know so. Who's Emily? Emily. Andrew. Guys, am I overlooking anyone? All the papers have been returned? Think? I know I got about 10 minutes. I'm proud of you. The scores. You jumped from 3 perfect scores to I think it was 7. The number of A's increased. Okay, and I hope to get some good results tomorrow. Now, guys, again, we'll try to be here at 11:15. In that room 63. I hope that room 63 is packed with students before that test takes place. Just a little bit more practice. Did anyone get all 4 zeros on this? Or any? Oh, I see some hands going up. That's,
Yeah.
Jimmy, how did you try?
like my answers or what I did?
Yeah, what you do, what's your process?
I did let u equal x squared.
Look at that.
And then I factored.
So you made this like u squared times 5u plus 4 is equal to 0. That's without me telling you to let u be something. So you did it. Then you factored. U subtract 4. U subtract 1. You split these up. So far so good?
Yeah.
And you're a great professor. U was representing x squared, so that's x squared is equal to 4. This is x squared is equal to 1. And now I think I see the answers coming out. X squared is equal to 4, quadratic, little tiny quadratic. But I see right here the answer's gotta be 2 answers, plus and minus 2. And the one on the other side is also a small quadratic, and have 2 zeros. X is equal to plus or minus 1. And are those my 4